So hi, good morning, everyone. Welcome to this session called DeepPhish, Simulating Malicious AI. My name is Alejandro Correa. I work as VP of AI and Research at Sixtera Technology. And allow me very quickly, before I get into the whole content, to introduce myself. So I'm an industrial engineer with a background in financial engineering, who was able to change very quickly to do a PhD in machine learning. I did this in the University of Luxembourg, where I was working part-time also doing fraud detection models. I have been very close to the whole open source ecosystem. I used to do a lot of work as a contributor to scikit-learn. If you have done machine learning in Python, I'm pretty sure you have used scikit-learn at some point. And I'm also have been very active organizing data science meetups wherever I'm living at the moment. I have worked for a lot of different organizations, and over the last 4 years, I have been working at Sixtera Technologies as initially as chief data scientist, right nowadays as VP of research. So what I'm going to talk about you guys today, this is a summary of the whole of 3 research papers that we wrote this year. So everything that I'm going to tell you is actually on those research papers, and most of the things is actually I just put it yesterday on GitHub, so I will share all of that with you later. First, I'm going to talk about machine learning to detecting phishing URLs, then deep learning to detect malicious certificates. Lastly, the last paper, DeepPhish, Simulating Malicious AI, and for some reason I decided to do a live demo, so let's see how that goes. I'm very proud that I was able to put all the buzzwords in one slide. So what is phishing? And I'm pretty sure we all are very familiar with this, but I still want to get everyone into the kind of phishing that I'm trying to detect. So you have your average user, in a lot of cases, either financial user or consumer user, that receive tons of these kind of emails every day. So you need to change your password because your account has been compromised, or you receive more money, please log in into your banking account to confirm. The user goes in here, and most users, if there isn't any solution that block that access, the users are going to end up putting their credentials into those sites. And the fact is, we can talk about more complex things, and actually I love talking about more complex things, but 91% of cyber attacks still start with a phishing email. So we have still a lot of things to do in order to keep protecting ourselves and our users from phishing. So why phishing detection is hard? And I'm going to talk about, in a machine learning setting. So why creating a machine learning model to detect phishing is hard? You have the original website, and you have a lot of strategies that attackers use and actually change every year or so. So 2016 or 2017, we saw a lot of phishing attacks in which they were just putting images and screenshots of the original website. Why? Because the algorithms at that moment were looking for keywords. So they decided to do these kind of things to avoid being detected by such algorithms. Then we started using computer vision algorithms, so that strategy didn't work anymore. But nowadays, we see attackers using, at the beginning, they were trying just to replicate the website. Nowadays, they know the user is just going to put their credentials, so why don't ask for the social security number right away? And users actually end up doing that. So the ideal, again, machine learning phishing detection system is a system that receives the original website, They extract all the images, extract all the text, extract all the source code, all the references. Then you put that into a fancy, well, not really fancy, a random forest algorithm, and you get the probability of that site being a phishing. And these kind of algorithms actually work if you give them enough data. What is the issue? That the time per respond is actually it's actually quite consuming, and you cannot use these kind of systems on mobile devices. That is just not going to work. You normally need even GPUs if you want to use complex algorithms. So you can actually deploy very scalable APIs, but in a lot of cases, you are not even allowed to send all of that information into your API. So you need to come up with solutions that you can run very quickly on any device. And for that, we started to investigate some time ago why, if we use only the URL and use that as a very quick way to analyze if the website is being used for phishing. So what we created, our research question was, are we able with the URL to capture phishing patterns that allow us to quickly rank websites and then being able to scale if we have alerts or so on? So in order to do that, we collected about 1 million phishing URLs, most of them from PhishTank, but also from other sources or even internal sources. We also collect initially about 100 million legitimate URLs. At the end, we end up with about 1 million. The easiest ways to do this, to represent the whole internet, is to use common crawl. And then we feed all that information into, in this case, a deep learning model, in particular, a recurrent neural network. Without going into much detail about that, what is interesting is that each input of the neural network is one character of the URL. So what we are trying to do is to allow the algorithm to detect the patterns inside the sequence of characters of the URL. A more detailed explanation of the algorithm goes this way. So we put as an input all the characters of the URL. We do a process normally done as a one-hot encoding and an embedding. And finally, we add an additional layer called long-term memory network. The output is just a sigmoid. Sigmoid here is going to give us a probability of that sequence of characters being used for phishing or not. So right away to results on this one. So the accuracy of this algorithm with those 2 million URLs, almost 99%. And that is amazing if you take into account that you are using the URL just as a string. You are not doing any further analysis or even pinging anywhere. You are just using the string of characters. And with that, you are able to detect with 98% of accuracy that a URL is being used for phishing or not. And the good thing about this is that you can actually implement this on a mobile device without needing much resources. So basically, yeah, I did it. Awesome. And what happened here was two things. First, I ended up submitting my presentation for a 50-minute talk, so I have to come up with more things to talk about. But more interesting, though, detecting phishing URLs is a very good starting point, but it's definitely not enough. So one of the trends that we have been seeing lately is that phishing attacks are using web certificates. And I know that for some of you the answer of why is obvious, but let me elaborate on that. So in fact, by the end of 2017, almost a quarter of the phishing attacks were using web certificates. So what is a web certificate? And the issue, as you can imagine, is that for most users, it's just what gave them the green padlock and the secure keywords. So if you go to a user and just by adding a free web certificate into a phishing site, you go from the Ultrabank URL without the HTTPS, and then you go to the secure HTTPS in green with a green padlock, what can you imagine your average user is going to think? So actually, Forrester did a quick survey asking users what does the green padlock and the secure keyword means. And what do you think the users responded to that? How many users are going to respond that the communication between the web page and the server is encrypted? How many users are going to say the website is safe? So in fact, 82% of the users say that the website is safe. And that's scary because how much does it cost to an average attacker to put a web certificate into a phishing site? In a lot of cases, nothing. It's just, and you can do that programmatically, so it's actually very easy thing to do. A lot of users say that the website is encrypted, 75%, even though that is not the complete answer, it's the most closest one to the actual one. The website is trustworthy, and the website is private. But the first one, the website is safe, we all know that is not true, but we have been teaching our users that when they see a green padlock, it's because everything is safe and you can click there. And suddenly we decided to put that information to the user, probably giving them more context, but it's technical context that they are not going to actually understand. So there is not surprise that attackers are nowadays using way more web certificates on their attacks. So we cannot really rely on the users thinking about, first, teaching them what encrypted means, different from crypto, so another, even more complicators. So we did another research project, and this was at the end of last year, called, the long name, Hunting Malicious TLH Certificates with Deep Neural Networks. More simplistic, we wanted to fit web certificates to a machine learning algorithm to be able to tell us which web certificates are going to be used or follows the patterns of malicious web certificates. So we collected, a million legitimate web certificates from Common Crawl, about 5,000 phishing certificates when we were doing this analysis. Nowadays, we were able to collect more. The hard part about collecting web certificates is that you can only get them while the phishing website is live. So collecting phishing URLs is easier because you can go and if the site was already taken down, you can still collect that. But web certificate is harder. And very quickly, this is just a hint of what we were able to do. You can see that the phishing certificate tends to contain the standard information normally used by Let's Encrypt. So you see a lot of examples.com, localhost, that local domain, because at the end, the attacker does not want, his whole objective is to get that secure keyword, not really to put any additional information there. So we were able to start seeing those patterns, and it's what we end up seeing that the algorithm end up doing. So in this case, we fit all of those web certificates into a deep neural network. In particular, this is the architecture of that neural network. It contains a lot of layers, some long-term memory networks combined with some dense layers. It looks complex. because we were submitting that paper to a machine learning conference. Not really because you have to make it that complex. Again, all of that is on the paper if you are working on this particular field. And the results were that we were able to detect the usage of a web certificate for phishing with 86% of accuracy. And that is amazing if you take into account how little information you can find on a web certificate. So just by using these kind of algorithms, you actually are able to, of course, not with a very, it's not a deterministic model, so you are going to have some false positives. But this allows you to filter very quickly all the web certificates that are passing by your network, and everything that have a very high score according to some of these models, you can put them as an alert to further investigate. Of course, something that I'm well aware is that just by doing this presentation, I assume some attackers are going to then make more complex web certificates. At the end, it's something easy to do. At that point, I will probably will have to go back to the drawing board and check how make my algorithm even more complex. But the point here is that using these tools in a very specific using machine learning in a very specific scenario with a very defined objective is actually very feasible and actually helps you to enhance a lot your whole process to be more proactive. Because if you are familiar with this, currently the way the browsers analyze web certificates, they just check if the web certificate is on a blacklist. With these kind of tools, you can be way more proactive. But once more, I'm here heading to the big part of my presentation. So every action has a fraudster reaction. This is probably the only slide that I allow my marketing department to put on my deck, but I like it. What is the latest trend? Well, actually, what is the latest marketing trend? Some AI cyber attacks will be almost impossible for humans to stop. 6 ways hackers will use machine learning to launch attacks, and how AI can be applied to enhance cyber attacks. So we start seeing a lot of these articles last year. And when I was walking into either one of these conference expos, it was very interesting to see a lot of vendors talking about this, but unfortunately, there wasn't any technical guy explaining me how that was actually doable. So I decided to assign 2 guys of my team to work on how can you enhance the attacks of a cyber criminal. In particular, how can you create a system that creates better phishing attacks? And the way to evaluate that is actually how can you bypass our own systems. So we end up creating this research project, DeepPhish Simulating Malicious AI. And the process of a project goes as follows. So first, the experiment, we needed to identify individual threat actors on the phishing on the phishing side. So we needed to know this set of phishing attacks belong to the same threat actor. Why? Because we needed to be able to analyze how their current strategies and which are their current strategies to creating those phishing attacks. So then we can then we were able to create a system that uses AI to create new phishing attacks. So that was the experiment that we created. First, as I was telling you, we needed to uncover the threat actors. And the thing is that when you are analyzing financial phish, it's normally a strategy in which the attacker wants to deploy millions of attacks with the less effort as possible, and meaning you normally don't have time to stop and analyze which threat actors are targeting which particular financial institution. So it was important for us to go back and actually understand different strategies used by different attackers. We, of course, were not able to see that directly, so we needed to learn that from the actual attacks. So we had a database of about 1.1 million confirmed phishing URLs, and what we did, though, was a very manual process in which we look for common domains that we found on phishing attacks. In this example, it's a domain that is clearly a compromised domain. It was an antiques e-commerce. We found about 400 URLs that were hosted on that particular domain. And we then go and did a manual process to analyze which were the keywords that they were using, how similar are the screenshots of those particular phishing attacks. And what we did then was to look for those keywords in the rest of our database. And again, this was a very, even though we work on machine learning, we have to do this manually because there wasn't any other way to do it. We found 106 domains that we were able to correlate to the initial domain to say all of these attacks are coming from the same threat actor. Also, we compare all the screenshots from the phishing sites, either because we had the screenshots or they were hosted on the phishing detection system, and then we were able to say all those attacks are belonging to the same threat actor. That was extremely important process for us because that allowed us to understand better which are the strategies that they are using. We did this we iterate doing this a lot of times, and this is an example of another threat actor. Again, same strategy, but arriving to a completely different targeted institution. We keep doing this, but at the end, I'm just going to focus on these two threat actors. So as I was telling you, now that we have all those attacks and we identify which threat actors were doing that, we wanted to check first how effective they are and to be able to actually compare and to create a metric such that we can then go and create new phishing attacks from their side. This time, for some reason, I decided to do this in a very interactive way. So allow me to regret this for a lot of time. Oh. Awesome. So I did all of this on Jupyter. If you are not yet using Jupyter, please do it. It's amazing. And what I'm going to show you here is like the whole process. All of this is in GitHub if you want to look at that later. So these are the set of URLs that we had from that particular threat actor. All of this is after we did that threat actor identification. So I start this notebook with the actual URLs used by one threat actor. These are the domains that were used. So 41% of their attacks were hosted on that first domain, and then we have 199 more domains that were used by this same threat actor. And the first thing that we wanted to do, though, was to evaluate the current efficiency of the threat actor. Here I have to be very clear. The difference between the efficiency rate and the actual success rate is that if success rate means how many credentials they store, or actually how much money they store. But that is way out of the kind of information that I have on this data. So efficiency here means how many of their attacks are bypassing my own AI detection system such that they are able to, such that the end user is able to see it. So that is very important to keep in mind. So here I'm using just an API of the first part of my presentation. That's it. You don't have to use that algorithm. You can use any algorithm you have that is core URLs. And then I analyze all the individual attacks to check. I was going to do this in a live animation, but if you have ever used MATLAB and Matplotlib, this is going to break, so I just recorded. So what I'm doing here is that I'm passing by all the individual URLs. When there is a red, it's because the algorithm did not detect it. And what we have here is the actual phishing score distribution. So I would expect everything to be concentrated here close to 1, meaning 1 that the website is phishing. And this will be the percentage of URLs that are blocked and the percentage of URLs that are actually effective. All right, so let me go to the end. Oh, of course. Actually, I have it here, the last one. So what does this mean? That the current threat actor strategy is having an effectiveness rate of 0.7, meaning 7 out of every 1,000 attacks are bypassing the detection system and are actually being shown to the user. So it's a very, very low rate and something that that normally you will say, that's enough, this attacker is no longer going to bother me. And exactly the reason of why we end up doing this project. So what we wanted to do next was, what is special about these 7 attacks? And how can we create an algorithm that learns the patterns of those attacks? So let me go further here. And this is the first summary of the actual algorithm. Again, all of this is on the slides, but I also put it here. So we separate the non-effective URL from the effective URLs. We wanted then to create an algorithm that learns the patterns of the effective URLs. For that, we extract all the strings of those effective URLs. We create that into a corpus, so we concatenate that and create a whole dictionary of the sequence of those characters. We applied encoding, and then we set all of that into the model. How the model looks like. So let me jump here. So this is what the model is doing. So the model is collecting the sequence of characters of the effective URLs and then predicting which are the next 3 characters according to the pattern seen on the effective ones. For that, we use 1 layer of LSTM network, 1 layer of hyperbolic tangent network, finally a softmax. What this is doing is that out of the whole possible characters that can go next, is going to predict which is the most likely character use according to the known effective ones. All that complex slide is actually just these 6 lines of code. So more or less, this is all you need to create exactly that deep neural network. It suddenly doesn't look that complex now. So the algorithm has 112,000 parameters. This is actually, if you have a GPU, this is something that you can train in under 10 minutes. This is the whole process of training. Again, I was not going to do this live because trusting of my GPU working during a live demo was even, yeah, I was not going to be able to risk that much. Then how do we use that algorithm? So once we know, once we have the algorithm that knows the sequence of the patterns of the effective URLs, we use the algorithm to predict which are the next characters in until we create a full URL. We apply that to the known compromised domains that the attack already have. So the attacker already own nailer and ticks. What we are changing here is that the path of that URL is going to be replaced to the path created by the algorithm. And at the end, with that, we end up creating a whole new set of URLs that the attacker now can use in this case. So again, this is the whole code to create that. What it's doing, though, is that it is just generating new paths, and this is how some of the paths that are generated looks like. So all of these URLs were actually created by the algorithm. And what we start seeing, though, is that a lot of the keywords that end up appearing here are the keywords that the first algorithm did not show, meaning our detection system did not show. So it's very, very interesting that you are able to create this using that simple 6 lines of code. So we created another 1,000 of these URLs. And again, let me show you what is the effectiveness of that. So what we did after was we evaluated all the URLs also against our own phishing detection system. So we wanted to know now how effective are they. Let me go here. So in this case, everything that goes red in here is because my system, my AI detection system, is not seeing. In here we have the percentage of URLs that are blocked is getting close to 75%. Remember, the original set of URLs were being blocked in a 99.2%. By using the algorithm is learning how to bypass the AI detection system. So in fact, you can put it in a way the AI is learning, this AI is learning what the AI detection system did not learn, which is kind of amazing. So I'm getting close to the end. Yeah, so right now it's converging. And at the end, we got something, we got this. So actually, let me go right into a comparison. So these are the original URLs in red, in blue, the one created by Swordfish. So there are a lot of URLs that the phishing detection system is saying they are legitimate, when in fact, everything here is malicious. The actual numbers, this is the comparison between the initial effectiveness. No, excuse me. So initially, the attacker had an effectiveness of 0.7. Right now, he got into an effectiveness of 29%. So let me go back here very quickly. So actually, all the other lights were in case my demo did not work. So actually it worked. So what is different here, I'm also adding the second threat actor that I was showing at the beginning. We already know the first one. Actually, in the last iteration of the demo, it went a bit higher. For the other one, they used to have an effectiveness of 0.9. They went up to 36%. So yeah, attacks are real, at least in this very specific scenario. We're doomed, or at least that is what I'm sure my marketing people are going to say, but let me go more in detail. So AI-powered attacks are real, as we show with this experiment. And the whole objective was to do it as realistic as possible using tools that the attacker may use. So, well, all the code that I put there is actually very easily to recreate using deep learning tutorials. It's not something that is complex, it's all using public available information, and it is also using open source tools. So just Python and Keras. So it's extremely easy to create these kind of things. What we need to do to actually defend ourselves is to, first, we need to know this may be something that the attackers are doing, and we have to test how they can do it before they do. So we need to enhance our own AI detection system to account for the possibility of attackers using AI. As I told you since the beginning, all of the things that I have been talking about is actually on these research papers. Everything is not on the GitHub, but there is a link on that GitHub, and otherwise I will be happy to share that. So, thank you. I have some time for some questions. So at this moment, I would like to open the room for some questions. Sure, thank you.
Hello? Yeah. So you've basically used generative adversarial networks to train one network to fool the other. Is that correct?
Yes, exactly.
Yeah. So in this model, you increase the effectiveness of bypassing a network, but have you estimate the increased or decreased effectiveness of actually fooling the user in terms of the phishing attack itself? Because you can create a URL that would look to your detection network as a legitimate attack, but would look very suspicious to the user.
No, yeah, for sure. That is why I have to separate the definition between effective and successful, because you could eventually bypass the detection system by creating something that will be obvious to the user that is a phishing attack. That may end up happening. What we have been seeing, though, is that if you look at a phishing attack in a mobile device, the user is not even going to be able to see the URL. So that while that you're saying is true, we have been seeing that users don't really are well informed to look at the actual URLs and do that analysis themselves. So this will be way more interesting if I have the data regarding which attacks were successful at getting credentials. But unfortunately, that data, I don't have it, and I don't think it's that easy to collect. In that case, this will be even more realistic. You may think, though, that the attacker do have that information, because the attacker do know which of the URLs are actually getting him money. So they will have even more data to create this more targeted towards that particular end. But indeed, what you're saying is true. I'm detecting efficient URLs, not successful URLs. That's right. Thank you.
Thanks a lot for that really interesting talk. I just wanted to know, where can we find the notebooks on GitHub?
So if you look, so actually my GitHub name is the same one, Al Bansen. I just put that yesterday. I'm sure I will tweet that after we finish here. If you have any question, please let me know there.
Hi. Also, thank you for this very interesting information. I've got a question regarding the certificates being used in the phishing attacks. Do you have any kind of information on breakdown? What kinds
Of what, pardon?
of a breakdown of what kinds of certificates were being used? Was it mostly like SAN certificates? Did you see any ones that had enhanced validation?
Oh, yeah, for sure. So actually, I have a nice table about that on the paper because indeed, you will not expect to see extended validation certificate on phishing attacks. That's for sure. The issue, though, is that there are a lot of legitimate websites that do not have extended validation. So that kind of simple rules will help you to only make sure that the user is logging into a top 10,000 Alexa, not even 100,000. Also, domain validation is not something that you see because all of that first costs money, takes time, and make more obvious who is creating the web certificate. What we see, attackers using Let's Encrypt or even paying for very simple certificates.
What is your strategy about redirects? I'm thinking in particular two kinds. Something commercial, like Bitly, or something more complex, checking for a real user browser behind.
No, yeah, what you're saying is completely true. Here, I'm only using the end or the destination URL. I'm not, if I use here the short-term URL, this will simply do not work. How I end up working with that in practice? Of course, you try to follow the link, but attackers are already blocking that because they are able to see you are doing that from a known vendor IP or something. So you end up having to create more complex pipelines in which you have to follow that shortener using geolocation, taking into account geolocation. You see a lot of attackers that suddenly, if the one that is trying to redirect is located outside the country they are trying to attack, they are going to block it. So you have to also take that into account. I will say for my side, meaning the research part, that is an engineering problem that we had been working on that, making sure we redirect using a lot of proxies, a lot of locations. At the end, I just get here the nice, clean data set, but that is the kind of things that you have to do in order to bypass that strategy used by attackers.
Did you try to use the output of your DeepPhish to retrain your model, detection model?
So the next AI paper that we are writing is how to make that in a very adversarial learning environment. So there is a continuous retraining with the new data that we collect, so sorry, I was answering that in a very machine learning way. So in a more general context, if we know which are the URLs that after doing DeepPhish the algorithm is not detecting, well, we retrain the initial algorithm and use that as also malicious URLs, and we keep doing that. There is a whole field of machine learning called adversarial learning that take care into that, and we have been working into doing that. We have not finished that paper, but there is a deadline that like in 2 weeks, so we will do that soon. I make sure to share that with you.
Hello, thank you for the talk. Just a question to the initial training.
Can you?
Okay, sorry. Because you described how you build up the neural network with the initial training set, but where do the 0.7% refer to the data set from the training or to a randomized set? And what would be the detection rate in a real environment in terms of false positives?
Yeah, for sure. So all those numbers are actually out of the 5-fold cross-validation. So we actually have to do it that way, like the right way. in a real-world environment, what happened? You have a lot of different scenarios. First, you try to use this for a general, as a browser plugin. Then you are going, that 0.6 of false positive is going to mean a lot of websites, because an average user is going to be in 100 websites per day, so that will grow up. How we end up using it, we use this in a more triage way. So we know things are suspicious, or we know this is suspicious because some other particular thing is happening. In that case, we analyze it differently. At the end, we end up implementing a lot of versions of the algorithm. One trained towards financial users phishing, one trained towards looking at actually just the resources used to be able to analyze weblogs, another one for more e-commerce kind of phishing, but it also depends on your use case. I use a balanced data set to train the algorithm, and you may very well argue the internet is not balanced. The percentage of phishing is very low compared to the whole set. So it really depends on the use case. A triage way is the right way to put these kind of tools into production. Otherwise, you will be having a lot of false positive, definitely.
So I was just wondering, when you mentioned these adversarial networks, if I could get hold of your algorithm and I train my own gun, would I actually be able to render your service inefficient? Because my generative network can produce exactly learns what you cannot predict.
So definitely, I mean, that is the question. Should I come to Black Hat to show my algorithm, but then an attacker is going to figure out a way to bypass this specific version of the algorithm? And the answer is, for the community to grow, we have to share it and be proactive into retraining my own detection system faster. That is the right answer. To a specific of what you're saying regarding GAN, the generative algorithm is unsupervised, so it's just going to create URLs. I will have to use more interesting semi-supervised versions of GAN to be able to actually just generate effective URLs and so on, but more on that part of the question. But overall, I think that we are better protected if we are able to share this, even if I know I'm giving a lot of insights regarding how to build malicious web certificates, for example, but we have to do it.
Obviously, yes. Thanks.
Sure. Okay.
Here's your mic.
Does your algorithm actually update its web certificates? Obviously, if a website is registered like every day, even more than that, does it update as it goes along, or is it like, a day update where you could have like those last 3 hours where it's not properly updated and then it has a higher chance of you being hit from a phishing point of view?
So in that case, it's more onto the pipeline of the engineering part. So the way I work with this, I create these algorithms and I expose them as APIs, and depending on when we are receiving that the user is getting this particular web certificate, we go call them, store it somewhere, and keep updating that for every single suspicious web certificate to try to avoid that kind of things. But again, once you create the algorithm, it's very easy to just do that automatically every second you want. Okay. So I have time for one last question. Or not. Oh, awesome. Thank you.
Thank you. An easy one to finish. So are you aware of tools which are similar to what Swordfish is doing, and did you try DeepPhish against that? Do you think it has any chance to succeed?
So that's a very good question. So indeed, when we were writing Swordfish, we went not really tools, but actually on the academic literature with which other algorithms were available. We haven't tested that against DeepPhish, so it was very using our own detection system. What I expect is that the actual DeepPhish does not really care how you build your URL classifier. It can be a blacklist. It doesn't really care. It will then learn how to bypass the blacklist. As I say, you can do it my way. There are a lot of other ways to do it. It's just the algorithm learning how to bypass that way to do it. So thank you for that last easy question indeed. So thank you, everyone. My contact information is there. I will be happy to answer more questions. Thank you.